Hello everyone, and welcome back to a new episode of Silicon Zeros. In the last episode we were about to start on instructions, but we managed actually to crash the game. In between the last episode and this one, I showed this video to Pleasing Fungus, and also the error log that was printed, and between us we were able to figure out how to reproduce the problem, and he says that he's fixed it. Although I won't see that update until tomorrow, so I'm just going to be a little bit more careful with creating stuff in my palette, try not to crash the game again. So anyway, we were going to try to decode instructions, so we got this new thing called an instruction decoder that takes a thing in memory. Can be more than just a number, it can be an instruction, which I suppose is really just a large number, but you interpret it as an instruction and get out these things. So our job is to implement a very small part of a CPU, I guess, implementing something that can handle a single instruction. And I guess in the future we'll flesh it out to dispatch based on what the instruction is. At any rate, this shouldn't be much going on here. We just need to load up our counter here, which is here. There's a counter. And can I make this go away? Yes, very good. There we go. Well, look at that. It's printed out in 0 mem on 74. So 0 mem, I guess, is a 2. So that's its if you interpret it as a number, it comes out as a 2. Is that right? Oh, it stores as 0 mem. Alright, well, whatever. Yeah, and if we pass it to an adder, we would get 1 plus 0 mem, which is 2, and the output would be 3. Okay, but we're not actually doing that. Instead, we're just taking this and opening up a writer, like that, to this memory slot. And I don't have permanent access to any zeros right now, so I need an additional number as well. Alternatively, of course, I could use a subtractor and subtract 1 from itself, but it doesn't seem to be any particular reason to do it in the silly way. There we go. That looks nice, doesn't it? Okay, so that should do it, right? Go? Yeah, we're putting zeros in memory where we were supposed to. Awesome, I should explain what's up. We're going public in a couple months. Zerocom's going onto the stock market. We need to have a product by then. Jack thinks we can sell generic widgets, but there's already plenty of widget companies out there. We need to make something new, something big. Oops, too loud, gotta go. That's right, he was whispering to us about, I didn't want anyone to know we were working on this. So we did instructions. We could go look at set memory. That should be pretty simple, right? I'm the one who told Fred we gotta work on this, codename Silicon Zeros. Oh, is this Carolyn? No, Carol. We gotta build a computer like nothing seen before, one that fits in an office, not a warehouse. We want you to work on a CPU, a machine that runs programs, lists of instructions. Decode and execute the memory set instruction in each slot. Okay, so we have a bunch of memory set instructions. We don't have to worry about dispatching yet. So source says set memory slot 89 to the value 6. Alright, this is easy enough, right? We'll just go back and grab this guy, this whole thing. Copy. Now, can I paste this outside of the thing? I don't remember. Paste. Nice. Okay, so instead of this 0, we will take this. And that's the only change, right? We're doing the whole thing where we read instructions from increasing memory addresses but instead of writing a 0, we're writing another part of the instruction. So it actually takes, it's a more advanced program, but it takes fewer modules. How nice. Great. What in Sam Hill? I don't think Sam Hill is actually, that might be a mishearing of that, like, I don't know, maybe I'm wrong. How many resources have you put into this? How much time have you put into this? We're sure as heck not making our deadlines now. We'd all better start looking for new jobs unless you think you can fix this mess. Personally, I'm not holding my breath. Okay, cool. So that was set memory, pretty simple. I get the feeling that we're going to want to copy most of that puzzle into like a new pastable thing, since reading an instruction from memory is going to be pretty important, I suspect. Cool, so we can't do dragging yet because we haven't learned the stuff in this branch. So let's do 3s before we move on to this 1s and multiply stuff that's ultimately leading towards the more advanced CPU. Hey, you built that alternator I wanted. I've asked what's-her-name to do it, but I didn't think I guess she didn't hear me. Typical. Well, here's the follow-up. Build a machine that starts at 0, sets every memory slot evenly divisible by 3 to 1, and the others to 0. Okay, so it's the same, I think. Alright, let's go grab our solution to alternator. And I was thinking actually that this right here would be a good thing to copy, is this sort of 2-step alternator. But I'm not sure exactly how to adapt it to be 3-stage. Obviously, we can just add another latch over here. But I'm not sure how to get out a value. I guess we can just add 1, subtract 2, basically, right? And then do something. Yeah, this should work out, I think. Assuming we have access to all of our parts. I don't know that I'm going to be doing it in the most efficient way, but okay, so what do I have here? I have adders, subtractors, and a latch. Well, that's a little bit limited, but I guess it's all I really need, right? No, I would have liked an input selector. So we need a 1 and a 0. Oh, do I just need another latch? Because we're going to be putting these alternators in a loop, right? Like this. They're going to be cycling. And we need there to be 3 values traveling through the cycle. And we need 2 of them to be 0s and 1 of them to be a 1. So we can, I think, just do the exact same thing as we did before, but add another latch. Not add a whole latch/adder pair, but just a latch. Alright, let's see how that looks. So let's paste this in. And so to store, so we need to put something here, right? And I guess I need the counter as well still. So send this here. No, not there. What am I missing? Okay, so some of the problem was that, okay, these 1s are supposed to have gone here. Okay, great. Now what do I actually have a counter here for? What is this counter doing? It's going to be the memory slot. So it looks sort of like this latch is somehow this counter is somehow driving this alternator, but it's not. The 1 is driving both the alternator and the counter, curiously enough. Okay, so here we're going to say that's the memory slot. What we write is going to be something like this that starts at 1. So we want to grab this, but just slap one more latch in the middle here, basically, I think. So take this 1, well, go like this, basically, right? So it turns into a 1. I think that what this is going to do is it'll be a 1, and then it'll immediately go back to being a 0. But meanwhile, the 1 will be traveling through these latches at a rate of once every 3 ticks. So let's see how that looks. Yeah, there's that 1. And the 1 is continuing to move. It's in this latch now. Now there's a 0 here, not a 1, but there's an adder that's turned this into a 1, and we're gonna, okay, great. This is a bit, I don't know, like, seems a little overly complicated. Dana, you just won me a pretty handful of smackaroos for my Saturday night drinking buddies. They were sure that technology just wasn't ready for a machine like this, but joke's on them. No, I don't know any practical use for this. That's not important, though. What is important is that I don't have to pay up. With the way I choose bets, let me tell you, that is a true revolution. You're a lifesaver, Dana. Well, that's rude. Ideal. So it wants me to note, I guess, that we can do it with 1 fewer module, huh? Interesting. I think we need the 3 latches. We clearly need the number 1. We need a counter. This is given to us. And so the only thing that we could possibly remove would be an adder or a subtractor, right? Interesting. Maybe there's some other way to do it with fewer latches? Because I think we need to add a value and then later subtract that value back out. Well, okay, I'm not going to stress about it. I'm not a perfectionist on these kinds of games. If there's not something interesting and easy, I usually don't bother to optimize once I've solved the puzzle. Looks like you're done with the input selector. Great. Here's an output selector. Replace all zeros in memory with 1s. Remember, we don't have much time before you chuckleheads run out of cash. Get cracking. Alright, so we want to replace zeros with 1s, but otherwise do nothing, huh? And I have an output selector. Passes its input to one of several outputs. Okay. Well, we're gonna want a counter. And we need a writer. Writing the memory slot from the counter. But what do we need? What is an output selector good for is what's a little bit curious to me. Is this just like, because we did basically this already with an input selector, didn't we? And this is just showing me that you can do the same thing with a different thingy. All right, and we need a reader as well. So we're going to read what's in the slot, and then use that as the slot number. So we're turning zeros into 1s, is that right? Yeah. So input should be a 1, which we have. And we'll just wire this one up to the output, and this one goes nowhere, I think. So if we get a 0, then we send the 1 up to here, and otherwise we don't. And I think that's all it takes. Well done! We're really moving Zerocom forward. I'm glad we get along with Jack. He's right that we need to put Zerocom on the stock market soon, though. I looked at our books, and we've been spending money so fast I could almost think someone was embezzling it. Haha, just a funny thought. I trust every one of you completely. How nice. Oh, we can do flip before we do... Oh, I see. Multiply is kind of an optional one here. Oof. Alright, I'm scared. I don't want to do one of these. I think we're getting sort of close to the end of the video. I don't want to dive into something too complicated. Okay, this is it. You're out of time. Replace all zeros with ones and all ones with zeros. Okay. So we have an output selector only. We have readers, writers, okay. So here's our counter. I feel like I should start grabbing something that, like, save something that writes to a particular memory. I don't know, there's not much in it, I suppose. Okay, so here's our counter. We need to read what's there, and then do something with it. So the 12 we're leaving alone, right? Yeah. So I guess we have an output selector. It would be easy enough to do this with an input selector, I think. Wouldn't it? Because I would just look at the value and look it up in the input selector's lookup table. Turn a 0 into a 1 and a 1 into 0 and leave everything else bottom. Ground, I don't know what the right word is for CPU stuff. And then just send that to the writer. But with an output selector, it's a little bit trickier, isn't it? Okay, do I have a subtractor? No, I have an adder, but I can add -1. So what I was thinking is that doing this 1 to 0 and 0 to 1 thing, that's the same as subtracting the value from 1, provided that it is either 0 or 1. And so we could use... We could apply that function, subtract from 1, to the input to determine what the output should be, and then use the output selector just to control whether that output is written or not. And we still could do that, because we could create a number with a -1 in it. But that sort of lacks elegance, I think, having to create the -1. How else could we use an... It is just an output selector that I have, right? Yeah, okay. So, can we use this to control the memory slot to write to? I don't think so. Sorry. Yes, we totally could, right? Either write to the current slot or to nothing. But that's not really any better than the alternative that I was proposing with subtracting from 1. Oops. So, how do we use this to control... If we're using this in part of the pipeline that produces the output value, then it kind of has to... If it's... only one value can travel through an output selector, right? So we kind of need to apply a function to decide what to do to the output selector. Yeah. Okay, so I think I'm going to go with this adder idea. So I'm just going to make another number here at -1. And give me also an adder. We're going to take this and add -1 to it. Hang on. The wrong way around. Isn't it? Oh no, I want to subtract from 1. So that's not actually quite so easy to do, is it? Because I need to negate the input value, not negate the 1. Adding -1 is doing me no good at all. Alright, so that idea is no good. But some idea has to work. I mean, I could just sort of build the stuff that I know I'm gonna need and hope that inspiration strikes me. So let's build a writer here. And do this. And we're gonna somehow need to use an output selector, apparently. And we're gonna write 0 and 1 to here. But why can I not do this? I can't have them both point to the same thing? I can't have them both point to the same thing. Well, that's what I was gonna do. Is have it write either to A or to B, which would point to the same thing, or to nothing at all. Ugh. This is... I think this is the first puzzle where I don't even know what the right approach is. Like, with the alternator, I just sort of had this, like, thought that, like, yeah, we need to somehow slow things down. But here, I'm not even sure what part of the problem I'm stuck on, because I haven't been able to break it down properly. I'm not yet familiar enough with the recurring concepts in this game to say, oh, yeah, okay, here's, you know, we need to apply pattern XYZ or whatever. I think that there must be some key way of using an output selector that I'm like, that's going to be important a lot in this game, probably, if you can use it to do this, but I don't recognize it. Well, so how do we even get... Let's forget about writing the value out, and let's forget about okay, so we can sort of Okay, so we had this problem with the output selector, right? Which was that you can't make its two outputs go to the same place. But you can sort of fake that if you want by sending it to two places which are identical. Get out of here, I don't want that. I wanted this. We can send this here and this here. Oops. Not here, but here, say. And then, like, send a 1 to both of these. I don't actually want to send this one, just for example. And now, if we put, like, a 0 in instead of a 1, then these adders are basically do-nothing operators that just take the wire from here and send it to here. Oh, but only one of them can be connected to this. Of course, you can't connect anything to the same output. It's not that you can't connect the outputs of this thing to the same place. Each wire can only be fed by one thing. You need an input selector to decide how to handle multiples. So we could make another writer and have that be how this thing controls. Okay, now I see how... Sorry. I see a way you could do this. I don't know if it's the right way yet, but we can have two writers, one of which always writes a 0 and one of which always writes a 1, and send at most one of them the correct address to write to, rather than sending the right value to a single writer. Send the right address to one of any number of writers. Okay, that should do it. So what we're going to do is build an output selector here, and it takes the memory slot as input and writes, give me another writer please, to either here or here, depending on the value that is read from memory. Hang on, this is... Where is this coming from? It's coming from the latch? That doesn't seem right. Okay, and its input... No, wait. Its input is this, and I guess its output is also... Or its selector is also this? Oh, no, its input, right, is the current memory address, which it forwards to one of... No. Right, okay. I think of both of these as being input, but one of them is the value we're inputting, the other is the control signal. This is the control signal, and the control signal is being fed by the value at that memory address. The memory address itself is the pass-through value. Okay. And so we don't actually send this to write, we send it to memory slot. And we just need access to another number here, number 0. So if the input was a 0, we should write a 1, so this goes here. And if the input was a 1, we should write a 0, and this goes here. Okay, I'm pretty pleased with this. So what happens? We're about to read a 0 from slot 0. So that means we'll select this 0, put it here. Memory slot 0, we're going to write a 1. So that way worked. Next there's a 1. And we've read a 1, so we're selecting and sending a 0 to slot 1. Hello, Dana. That is a nice looking machine, though I am not sure what it does. Have you seen Jack? He's supposed to join me at the offsite investor meeting, but he does not seem to be here. Well, I am sure he has some good reason. Have fun while I'm gone. Okay, cool. So that's actually the ideal solution, apparently. Neat. I like this one. It made me think in a way that I was not really prepared to think, apparently. Since it was... I couldn't figure out how to use this output selector to do what I wanted to do because I thought, you heard me say, is there some way I could use it to control the memory address to write? And I concluded that the answer was no. I couldn't use it to change what memory address to write to. And I therefore concluded that I must pass the input value. But that's not quite true. I was able to use this to control the memory address, not what memory address is passed, but rather where it is passed to, which had a similar sort of effect, but in a different way that I wasn't expecting. So anyway, that was, I think that's enough puzzles for this episode. They are starting to get difficult. I hope you guys are enjoying them. Thanks for watching, and I'll see you next time.